Section 6 is parallel and perpendicular lines. So everything we've done so far in this chapter up to this point has led up to being able to work with parallel and perpendicular lines. So we need to remember what parallel and perpendicular means, and then we'll see how it relates to linear equations. So what is parallel? What does that mean? So yeah, you see like train tracks or what else? Lines that don't cross. All right, so let me write that down. For parallel, notice that I have two boxes here. Over here, I'm going to write down parallel lines are lines that do not cross. These lines need to be in the same plane, so I'll put that on here. In the same plane. Lines that do not cross, that are not in the same plane, don't necessarily have to be parallel. So like think of the walls of a room. Opposite walls are parallel. Those are actually planes. But if you look at the lines that are made by the floor and the wall and the ceiling and the wall, then those lines that are made are shared by that wall. The wall is the plane, and the lines are the parallel lines that we're talking about. But in a room, you don't necessarily have to have lines in the same plane, because I could be talking about one wall and another wall, and then the line formed by one wall and the floor, and the line formed by the other wall and the ceiling. Those lines aren't going to touch, and they're also not parallel. So what does perpendicular mean? Okay, these lines do cross. So lines that cross, but there's something special about the way that they cross. At a 90-degree angle. Or in geometry terms, at a right angle. 90 degrees means a right angle. And we have a couple of symbols that we need to talk about. The symbol for parallel. Anybody know that one? That's two parallel lines. They look like L's. Two. Looks like what? Oh yeah, it kind of looks like the pause symbol. That's right. So it's two parallel lines basically. If you look at these lines, they're not going to cross. They're just vertical lines. That's our symbol for parallel. Another way to remember it, some people remember it because there's two L's sitting here in parallel, and those L's are parallel. They're not going to cross, just like the symbol over here, and that kind of helps you remember what parallel means also. How about perpendicular? We need a symbol for that one. It's a T, but it's a capital T, and it's upside down. Why would we choose a capital upside down T?
So that people don't mistake it for a regular T?
True, so that people don't mistake it for a regular capital T. Or the plus sign. But why a T? Why not a V or an M?
Because they touch.
Because right here we're forming 90-degree angles, that's right. So the capital upside down T helps us remember what perpendicular means. It means that the two lines that we made form right angles. So there is a reason why we chose these two symbols for parallel and perpendicular. Those are the reasons. Before we go on, I want to talk to you guys about parallel and perpendicular lines. See if we can figure out some information, because there's more that we need to talk about on those definitions for parallel and perpendicular. So what I have here is a couple of parallel lines. How do I know they're parallel? Because it seems like they never cross. Okay? What I'm going to do is move around these parallel lines. And I have over here, like this equation right here matches that line. And the second equation is for line K, right here, line K. So what I'm going to do is move these around. First of all, I have y equals negative 2.5x plus 2.5. And I have y equals negative 2.5x minus 3.5. So let me move this line around a little bit. Oops. I want the A. There we go. Helps if I look at the computer. So maybe there. Now my equation, my lines are still parallel because I've made them that way on this program, But now my equations are y equals negative x plus 4 and y equals negative x plus 5. So if I do it again, I'll just move this around and go like to here. And now my equations are y equals negative 7x plus 16, and y equals negative 7x minus 17. And if I do it maybe one more time to here, I get y equals x, and I get y equals x minus 1. What do you notice is happening each time with these equations and these lines? The slope is always the same. That's right. So the slope for this one is down 1, right 3. The slope for this one is down 1, right 3. It's the same slope for both lines. These lines are parallel, and they have the exact same slope every single time I move this around. I could now just randomly move A over to somewhere else. I'll put it up here. And now my slope is 0.25 for both lines. If I move it somewhere else randomly, maybe like there, now my slopes are both positive 7.5. But that's the idea. For these parallel lines, the slope is the same. So, for my definitions, I'm going to say for parallel lines, same slope. That is something that you absolutely have to know for section 6. Parallel lines have the same slope. Do they have the same y-intercept? No. If they had the same slope and the same y-intercept, we would see exactly the same line. And that's not what's going on here. Okay? We do have the same slope, but we don't have the same y-intercept. This looks like about 1/2 right here, and sure enough, 0.5. This looks like about negative 1.5 right here, so negative 3/2, and we see it sitting over here. So the y-intercepts will be different, but the slope will be the same. There's another, for perpendicular, there's also some sort of pattern that we need to see. So for this one, see now it disappears. For this one, I've constructed two perpendicular lines. We have line AB and we have line J. And I don't see the J on here anywhere, but that's this. Oh, there it is right there. So that's this line right here. Okay, now I've constructed these lines to be perpendicular. If I was to measure the angle that was made here, it would be 90 degrees. That's geometry. We're worried about algebra. So with these two equations, we have a slope here of 2 with a y-intercept of negative 2, and a slope here of negative what? A slope of negative 0.5 with a y-intercept of 3. So are these slopes the same? No, obviously not. I mean, you can look at the graph and see that they're not, okay? But there is a relationship that goes on in this equation. So I'm going to move this point around a little bit and put it there. Notice the two equations. Look at the slopes. Okay, I'll try another one. The lines are still perpendicular. Notice the slopes. I'll do another one. The lines are still perpendicular. Notice the slopes. Yeah. One's always negative, and the other is always positive. It's not necessarily one is always positive and negative, but we do have one is positive and one is negative. So like this one is negative right now, but if I move this point up here, now that slope is positive, but this one's negative. So let's try another one. Again, one is positive, one is negative. What else do we see? I'll try another one. Huh? Oh, yeah. That has nothing to do with this. We've got a slope of negative 2 on one of them and a slope of 0.5. What is 0.5 as a fraction? 1/2. Now we have a slope of negative 1/2 and a slope of 2. Now we have, let me get a good one here, a slope of negative 4, and what's the other one as a fraction? 0.25 as a fraction is 1/4. Okay, let's try another one. Now we have a slope of 5 and a slope of negative 0.2. What is 0.2 as a fraction? 1/5. Let me give you another one, see if I can really drive this one home. How about that one? Now we got a slope of 0.1, and a other slope would be negative 10. So we have a slope of 1/10 and a slope of negative 10. What's that? Yeah, you can't have fractions in slope. I mean, rise over run. But what about it? It's the what? One is positive, one is negative. One is 10, the other is, as a fraction, 0.1 is. So one is 10, the other is 1/10. If I make one 4, then the other one will probably be negative 1/4. So I'll make this one 4, and the other one is negative 1/4. If I make this line have a slope of 2, then the other line will have a slope of what? It won't be 1/2. If I have a slope of 2, then my other line has a slope of negative 1/2. If I have a slope of negative 1/2, then my other line will have a slope of positive 2. If I have a slope of negative 3, then my other line will have a slope of positive 1/3. If I have a slope of positive 4, then my other line will have a slope of negative 1/4. What's happening here? What are 4 and 1/4? What is 3 and 1/3? What's 2 to 1/2? They're reciprocals. And then the signs are opposites. So therefore, I don't want to get rid of everything. Come on. There we go. For perpendicular, our slopes are going to be called opposite because they have opposite signs every single time, and also reciprocals because they're always flipped. Opposite reciprocal slope for perpendicular. If I give you a slope that is 4, and I say give me a perpendicular line to that line, its slope will be negative 1/4. That's what opposite reciprocal means. Flip the fraction, change the sign. Flip the number, change the sign. Opposite reciprocal for perpendicular. So these two ideas right here, same slope for parallel lines and opposite reciprocal slope for perpendicular lines, are critically important in this section. And they're all over the chapter test, so you need to know them. So, first of all, we'll work with the equations for parallel lines. This is your typical problem in this section that you're going to see. It says write an equation in slope-intercept form. So what is slope-intercept form again? Y equals mx plus b. So that's what my equation is going to look like in the end. It says for the line that passes through this point and is parallel to the graph of y equals 2x minus 4. So my line is going to be parallel to this line. If my line is parallel to this line, then what will my slope be? If my line is parallel. Parallel lines have the same slope. So therefore, my line will have the same slope as this line. What is the slope of this line? 2. So therefore, my line has a slope of 2. And now, I know that m equals 2 for my line. If I know that m equals 2 for my line, and my line is supposed to go through this point right here, then I have everything I need right now to write the equation for my line. I can use point-slope form. So slope-intercept form came in section 3, but point-slope form came in section 4, and now we're in section 6 using those two things with parallel and perpendicular. So all of this stuff gets tied together. I'm going to use point-slope form to write the equation for my line. Okay? Before I do that, I want to graph this line, y equals 2x minus 4. So to do that, I'm going to put my y-intercept at negative 4. And my slope is positive 2 over 1. So I'm going to go up 2, right 1, up 2, right 1, over and over to get all my dots on there. Reverse it, go the other way. Okay, draw on that line. So I put that line in blue, and I'll change colors to give you my line that I'm supposed to have. This right here is going to generate my line. My line is supposed to go through negative 3, 5. It says, write an equation in slope-intercept form for the line that passes through negative 3, 5. Negative 3, 1, 2, 3, 5. 1, 2, 3, 4, 5. So my line is supposed to be parallel to the blue line, and it's supposed to go through that red dot that I just put on there. All I have to do now is write the equation, and then I can graph it. So the equation in point-slope form is going to be y minus y1, which is 5, equals m, which is 2, times x minus x1, which is negative 3. Put the equation down in point-slope form. Y minus 5 equals 2 times x minus negative 3. That's point-slope form. Now I want to put it in slope-intercept form because they told me I got to give the answer in slope-intercept form. And then I'll graph it and see how I did. So in slope-intercept form, I need to distribute first. I'll take care of this sign issue that I have and then distribute. Y minus 5 equals 2x plus 6. Then I add 5 to both sides. And I get y equals 2x plus 11. So it says write an equation in slope-intercept form for the line. I just did. 2x plus 11 is the equation for my line. So let's check it on the graph and see what we get. It's going to be kind of tough to do because it says we have a y-intercept of 11, and I only get up to 7 here. So I'm going to have to kind of imagine going up to 11. 8, 9, 10, 11. Now my slope is 2 over 1. Up 2, right 1. Or down 2, left 1. If I'm sitting here at 11 and I go down 2, then I'll be at 9. Left 1 puts me over here. If I go down 2 again, then I'll be at 7, which is right here. But then I got to go left 1, which puts me right here. Then now I'm on my grid, now I can apply the slope easily. Down 2, left 1, 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 and I'm out of space. That's how you graph this without having to change the scale and without being able to see your y-intercept. It's not a guessing game. The other way you could have graphed it is said, okay, I know that point is sitting right there, and I know my slope is 2, so I'm just going to go from here up to right 1, now I'm out of space, and then down 2, left 1, and so on. So that's how you can graph it. Now, do these two lines look like they're ever going to cross? No. They are parallel lines. They have the exact same slope. They have the same rise over run. Same rise over run. They have different y-intercepts. They're never going to cross. They're parallel lines. Okay? Now, notice that I did that sort of by showing the graph, but I did it all over here using algebra. I used the idea that we have the exact same slope for parallel lines. And as soon as I know that my line is going to have the same slope as this line, then I know that m equals 2. And because they gave me a point, I can use point-slope form to write the equation for my line. And then I just put it in slope-intercept form and I'm done. Don't even need the graph, really. I'm giving you the graph so you can see that actually this algebra is working. Another example, write an equation in slope-intercept form for the line that passes through 4, negative 1. and is parallel to the graph of y equals 1/4 x plus 7. Don't have to do this, but it kind of helps in the beginning. I'm going to go ahead and graph y equals 1/4 x plus 7. 7's right there. And then I got a slope of 1/4. I can't rise up and run to the right, so I'm going to go down 1, left 4. And that's all I can do on this graph. So I do have 2 dots, so that's good enough. I just have to be very careful about how I draw this in here. So there's my line. Now the line that I'm supposed to graph has to be parallel to that line, and it has to go through what point? So it has to go through what ordered pair? 4, -1. This point right here. 4, -1 is there. So my line is going to be parallel to the blue line that I just drew, and it's supposed to go through this point. Okay? Now if it's supposed to be parallel, what do I know? The slope is 1/4. It's going to be the same slope. So the slope in this equation is 1/4, which means the slope in my equation has to also be 1/4. So m equals 1/4. Now what? Use point slope form. So that's y minus y1 equals m times x minus x1. What do I write? Y minus -1 turns into y plus 1 equals 1/4 times x minus 4. So that is the equation. But they specifically said you got to write it in slope-intercept form. So now I put it in slope-intercept form. What do? Distribute. So we get y plus 1 equals 1/4 x minus 1. Don't need parentheses. And now we subtract 1 from both sides, and that gives me y equals 1/4 x -1 minus 1. -2. So minus 2. That's the answer right there. That's all I have to do for these problems. Technically, I don't even have to graph it. I'm just showing you the graph so that you can see that what we came up with actually is parallel. So I'm going to graph it, and we'll see. I have a y-intercept of -2, which is right there. I have a slope of 1/4. That means I rise 1, run 4, and that puts me right on that dot that I already knew I was supposed to go through. I'm out of space this way. I'll go the other way. Down 1, left 4. Now I'm out of space the other way as well. So I draw on that line. So, are those 2 lines going to cross? Nope, that's it. That's the graph. Didn't need to do it really, but it just helps to see that this equation actually is parallel to this equation. This equation goes through this point that they told me I needed to go through. So that was parallel. Now we'll do perpendicular. Same set of directions. Write an equation in slope-intercept form for the line that passes through -2, 3, and is, this time, perpendicular. So when you're reading these problems, you want to see parallel or perpendicular. And as soon as you see parallel or perpendicular, slope has to pop into your mind. If you see parallel, you should be thinking same slope. If you see perpendicular, you should be thinking what? Opposite reciprocal slope. Opposite means change the sign. Reciprocal means flip the number. Okay? So we need a perpendicular line to this line, which means that my line is going to have what for its slope? This line has a slope of -1/2. My line will have a slope of 2. Positive 2. To figure that out, you change the sign and you flip the number. So we change the sign from negative to positive. We flip the number from 1/2 to 2/1, which reduces down to 2. So now it's positive 2. As soon as I have that, I know that my slope, m, equals 2. And then just like on the last problems, I have a point and I have a slope. What can I do? I'm not asked to graph. Point slope form. So I just write point slope form and I'll have my equation. Times x plus x minus negative 2, which turns into x plus 2. I don't have to graph. On these problems, I'm not going to be asked to graph. I'll graph it once we're done writing this equation so that we can see that these two lines are in fact perpendicular, but that's not a part of this problem. As soon as we have a slope and we're given a point, we can go straight to the equation and we're just about done. So here's my equation. They still want slope-intercept form, so I distribute. Y minus 3 equals 2x plus 4. And then I add 3 to both sides to get y by itself. Y equals 2x plus 7. This is the answer. So we'll go ahead and graph it just to check. I'll graph the first equation that we were given in blue. We have a y-intercept of negative 4 and then a slope of negative 1/2. So I'm going to go down 1 and then right 2. And reverse it, up 1, left 2. And draw on that line. Now my line is supposed to be perpendicular, which means, am I going to see crossing lines here? Yes. And those lines should cross at approximately a right angle when I draw my graph. It should look like a nice right angle when I draw on my graph. So, draw on the graph. We have a y-intercept of 7, which is all the way up here, and then a slope of 2. I don't have any room to rise over run, so instead I'm going to go down 2, left 1, down 2, left 1, all the way through my graph. And then draw on that line. Okay, so does it look like those two lines cross at a right angle? Yes, it does. So I'm pretty sure then that I have the right answer. Does my line go through the point that I was given, negative 2, 3? Well, here's negative 2, and then up to 3, it sure does. So everything that I was asked to do with this line came true. It does look like it makes a right angle here, and it goes through the point that they gave me, negative 2, 3. It's easy to do. All you got to do is figure out what your slope's going to be. If they say perpendicular, change the sign and flip the fraction of the original slope, and you'll have your slope. Then use point slope form, your slope and the point that you're given. Let's see if we can do this one on our own, without graphing. We'll check it with graphing, but don't graph it. Write an equation in slope-intercept form for the line that passes through, negative 3, negative 2, and is perpendicular to the line y equals negative 2x plus 4. What is the most important word in that entire sentence? Perpendicular. You have to see this, and as soon as you see that word perpendicular, you have to say to yourself, what? Opposite reciprocal slope. Okay? Which means that I need to look at the equation that I'm given, find the slope. What is the slope here? It's negative 2. Now to write my slope, I need to change the sign and flip the fraction. So it becomes positive. It was negative, it's now positive. It was 2 over 1, it's now 1 over 2. There's my new slope. You have to see that word perpendicular, and you have to think opposite reciprocal. Once you do that, it should help you remember that that negative 2 turns into a positive 1/2. And as soon as you've done that, all the information you care about is sitting right there. The point and the slope. Put it in point slope form. Y minus negative 2, so y plus 2 equals 1/2 times x minus negative 3, so y plus 3. Then distribute. Y plus 2 equals 1/2 x plus 3/2. All right, so we got a fraction to deal with here. It's not that big of a deal. Subtract 2 from both sides, and we have y equals 1/2 x. 3/2 is like 1.5. So I got 1.5, and I'm subtracting 2. What do I get left with? Negative 1/2. So there's your equation. I didn't have to graph it. Don't need to graph it. We will graph it just to make sure that we were right. So since I wrote all this in blue, I'll go ahead and graph that in blue. We have negative 1/2 as our y-intercept, which is probably like there. And then a slope of 1/2. So this is kind of a new one for you. We're using a slope of 1/2 from here, which means we have to go up 1 full unit. From here, that means I go all the way up to here. That's 1 full unit. And then a run of 2 to the right. Up 1 full unit, 2 to the right. Up 1 full unit, 2 to the right. Reverse it, down 1 full unit, 2 to the right. Down 1, over 2 to the left, sorry. Down 1, left 2. And there's my graph. So I draw that one in there. So be careful when you draw on a slope like that. But you can draw on a slope like that. You don't have to be exactly on grid lines to be able to do that. So that is my blue equation, and this time I'll draw the given one in red. We have a y-intercept of 4 and a slope of negative 2, right 1. Down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Up 2, left 1. That's all I got, so draw on the line. There it is. They look perpendicular to me. And our blue line goes through negative 3, negative 2, right there. So we satisfied all the requirements of the problem. Like I said, this graphing part isn't going to be asked of you most of the time. So this is not what you need to do. This right here is what you need to do. It's like one extra step. Figure out the slope, then plug it into point slope form and go to slope intercept form just like we did in section 4. All right, so now we'll get into a story type problem. Not that big a deal. It's the same idea, you just don't have an equation sitting in front of you. So on the plans for a treehouse, a beam represent, what's a beam? What does that mean? Yeah, like a piece of wood that supports the structure, whatever it is that you're talking about, like a beam in a ceiling or a beam in the floor. So on the plans for a treehouse, we're probably talking about like the floor of the treehouse. A beam represented by segment QR has these endpoints. Q is at negative 6,2 and R is at negative 1,8. A connecting beam represented by this segment, ST, has these endpoints, negative 3,6 and negative 8,5. Are the beams perpendicular? So what this is saying is, I got this beam QR. Maybe it's doing this. And then I got this connecting beam ST. So maybe this is Q here. And maybe this is R. And then I have this other beam that's going to come in and connect. Maybe it connects like right there. And they're calling that ST. Okay? We're trying to figure out if these beams are perpendicular or not. Now, since they've given me coordinates, based on the way I drew it, it looks like it's perpendicular, right? But I didn't use the coordinates at all. I didn't do any math. This is just a sketch to show you what it is that they're saying. So what they're asking you to do is try to figure out if these could possibly be perpendicular. How would we know if things are perpendicular based on what we've done so far in this section? What? How do we know if things are perpendicular? Yeah, the slopes would be opposite reciprocal. So they've given me, for QR, they've given me the endpoints of the segment. Can I calculate the slope? Yeah. And for ST, they've given me the endpoints of that segment. Can I calculate that slope? Now, if these are going to be perpendicular, beams, then their slopes will have to be opposite reciprocals. So that's all we have to do in this problem. There's no need to have a sketch. There's no need to have a grid to graph it. All you need to do is find the slope. So for QR, the slope m equals what? So y2 minus y1 over x2 minus x1. So we're going to write 8 minus 2 over negative 1 minus negative 6. I'm calling this one 2 apparently, and the other one 1, so be consistent. Okay, we have 8 minus 2, which is 6, over, what do I do here? So plus, and we get 5. All right, so my slope for segment QR is 6/5. Now what do I do? Find the other slope. So for ST, m equals what? 5 minus 6 divided by negative 8 minus negative 3. All right, so 5 minus 6 is negative 1 over, change that to addition, and we get negative 5. Negative 1 divided by negative 5 reduces down to positive 1/5. Okay, so there's the slopes for those two beams. Are these perpendicular beams? No. Okay, so the answer is no. But it also says explain. Why? Right. Slopes are not opposite reciprocal. So that completes the problem. You have to know that slopes for parallel and perpendicular are incredibly important. Perpendicular, opposite reciprocal. Parallel, same slope. All right, moving on. Identify the pairs of parallel and perpendicular lines. There are parallel lines in this, and there are perpendicular lines in this, and some of them might be misleading. So, go. Here's the best way to do this. You're given a graph. You have grids on there. You don't know anything about these lines. But with the grids, you can figure out the slopes. Because if I'm looking for parallel and perpendicular, then they have to have either the same slope or opposite reciprocal slopes. So, that means I have all these lines here. I'm just going to label them A, B, C, D, E, F, and G. And I'm going to figure out the slope for each one of these lines. And then I'll compare the slopes. And then I'll know exactly what's parallel and what's perpendicular without guessing from the graph. So for A, I need a couple of easy points. I got one right here, and then it looks like I got another one right there. That is a rise of negative 1 and a run of 3, so the slope for A is negative 1/3. Do the same thing for B. This is line B. I just need a couple of easy points. I got one right there, and another one right there. So this slope is what? Negative 2/3 is correct. For C, that's this guy. I just need a couple easy points. There's one. There's another one. What's the slope for this guy? Negative 1/3. All right, for D, here's my D line. I got a dot there and another dot there. The slope here is negative 1/2. For E, where is E? There it is. Couple easy points. There's one, and there's another. Slope on E is 2. A rise of 2, a run of 1. For F, here's F. We have an easy point there and another one there. What is the slope for F? 3/2. And finally, G is this guy. We got an easy dot there and another one there. What is the slope of G? 2. Now I just need to compare. Do I have any parallel lines? I'm looking for the same slope. So is there a parallel line to A? A is parallel to C. So I'm going to write A is parallel to C. A is not parallel to D. D has a slope of negative 1/2. If you were just looking at the graph, you might make that mistake. But as soon as I write them all down, I can tell. Do we have any other sets of parallel lines? E is parallel to G. Do we have any others? E and G we have. That's it. So let's look at perpendicular now. B and F. So B is perpendicular to F. Any others? D and E are perpendicular. D is perpendicular to E. Any others? A and not A. D and G. D is negative 1/2. G is positive 2. Do we have any other perpendicular lines? I think that's it. So that's how you would do a problem like this. Okay? A problem like this could easily show up on a standardized test like MAP. And they ask you which one of these is a true statement. And then you got to go through and try to figure it out. You do it just like this. Another type of question you can be asked, are the graphs of this equation and this equation parallel, perpendicular, or neither? Okay, how am I going to do this? Yeah, put them in slope-intercept form because you want to compare the slopes. So this one here is already in slope-intercept form. This one, all I need to do is what? Divide everything by 4. So every little term gets divided by 4. And my new equation is y equals negative 5/4 x plus 3. So I got a slope of negative 5/4 and a slope of 4/5. Are these lines parallel, perpendicular, or neither? They're perpendicular. Explain. They have opposite reciprocal slopes. So when you're given problems like this, and there are some like this on the homework, you want to put it in slope-intercept form and then compare the slopes. If they're parallel, they will have what kind of slopes? The same slope. If they're perpendicular, they will have opposite reciprocal. And if they're neither, then what will you see? Neither, they won't be the same and they won't be opposite reciprocals. They'll be like 2 and 5/2 or something like that. Okay? So that's how you do a problem like that. But make sure you also explain